to another lesson. We're going to look at G.C.D, which is the greatest common divisor. And this is a very simple topic, but of course it's a very tested area, and we need to be able to understand on the same. So we have two methods, but these are not limited. We are going to look at the two methods, but we have got more than that of how to get the GCD of numbers. And one is using the table, and the other method is using the prime factor form. And I'm going to have an example here so that you can be able to see how can you be able to get the GCD of two number of given numbers using the two method. And we are going to have example one here, which we have been told to get the GCD of 72, 96, and 300. And we are going to first to use tables, and then we use the prime factor method to see how we can be able to get the GCD of two numbers. So let's start by using the table. So we want to get the GCD of 72, 96, and 300. So the first thing is to divide by a number that is going to find all of them. Of course, we use the prime numbers here. So you check the first prime number, like which is 2, whether it can be able to divide all of them. And in our case, it is. So we have 2 there. We divide by 72 divided by 2. We're going to get 36. Then 96 divided by 2 should be 48. Then 300 divided by 2 is 150. So we can divide all of the 3 numbers by 2 again. We're going to have this is going to be 18. 48 divided by 2 is going to be 24. And 150 divided by 2 is going to be 75. Then 2 cannot divide all of them again because of the 75. So we go to the next number. For the GCD, the number that I'm dividing here should divide all of them. So we check 3, and 18 is divisible by 3, 24 is divisible by 3, and 75 is divisible by 3. So we divide by 3 to get 18 divided by 3, 6. 25 divided by 3, get 24 divided by 3, get 8. And then 75 divided by 3, you get 25. Then there is no common factor that can divide all of the 3 numbers. So we settle for 2 times 2 times 3 as our GCD. So GCD will be 2 times 2 times 3, which is going to be 2 times 4 times 3, going to be 12. So that's how we can put together the GCD of numbers using the table. So the next method is now using the prime factor method. Notice number B, factor method. So we have 72. We write it in terms of prime factor form. By 2, you get 36. By 2, 18. By 2, 9. By 3, 3. By 3, 1. So 72 is equals to 2 power 1, 2, 3, 2 power 3 times 3 power 2. Then the other number is 96. By 2, 48. By 2, 24. By 2, 12. By 2, 6. By 2, 3. By 3, 1. So 96 is the same as 2 power 1, 2, 3, 4, 5. 2 power 5 times 3. Then the other number is 300. So write it in terms of prime factor form. By 2, 150. By 2, 75. By 3, 25 by 5, 5 by 5, 1. So 300 is the same as 2 squared times 3 times 5 squared. So for us to get the GCD, we are going to look for the number that appears in all of them, like 2. We have 2 squared, 2 power 5, 2 power 3 in all of them. Then we pick the one that has a small power. This is opposite of what we are doing in LCM. We're looking at the one that has the highest power, but for the GCD, we take the one that has the smallest power. And it has to appear in all the set of number given. Then for 3, we have 3 power 1, 3 power 1, 3 power 2. We pick one of the 3 that has the smallest power, either this or that. So I can pick that, no problem. Then 5 does not appear to all of them, so we leave it alone. So our GCD should be the 2 squared times 3, and the 2 squared is 4 times 3, which is going to give us 12. Again, you can see that using the 2 method, the GCD should be the same. So let's look at example 2 and the last 3, example 3, to see how we can be able to answer the questions on GCD. So question 2, example 2 reads that 3 similar steel bars of length 200 centimeters, 300 centimeters, and 360 centimeters are cut into equal pieces. Find the largest possible area which can be made from any of the 3 pieces. The keyword here, largest possible area that can be made from, of course, any of the 3 pieces. So, if the question is asking us for the largest, sometimes they can use the biggest, sometimes they can use the maximum. Generally, in that kind of a scenario, you may be required to use the GCD. And in our case here, we're going to use the GCD to be able to get the GCD of 200, then 300, 360, to know that size of the wire that can be cut from any of the 3 pieces. So the GCD of 200, 300, and 360. So you start with by 2 because all of them are divisible by 2. Get 100, divided by 2, 150. This divided by 2, 180. By 2 again, because of 50 there, 75 there, and this is going to be 90. 2 again, no, because 75 cannot divide by 2. Then go to 3. 3 now because of 50. Now the next one should be 5. All of them are divisible by 5. You get 10. 75 divided by 5, you get 1 because of 5. You get 2, 5, 25. Then 90 divided by 5, get 1 because of 5 divided by 4, 48. So these 3 numbers cannot be divided by, do not have a common factor. So our GCD in this case is going to be 2 times 2 times 5. And this is going to be 4 times 5, going to get 20. But we are not going to give our final answer to be 20 because the question is asking us to get the largest possible area. So the area will be 20 times 20. You get 400 centimeters squared. So that is how you're supposed to answer that kind of question. Then let's look at the last question, last example here. We have the question reads that the greatest number which can be divided by 181 and 236 leaves a remainder of 5 in each case. Our keyword here is the greatest number. Greatest number, or the largest number, the maximum number. Of course, most of those kind of questions, may require you to get the G.C.D. So we want to get the G.C.D of the 181 and 236 of that number that when divided by a number that when divided by 181 and 236 leaves a remainder of 5 in each case. So what we do this question before you get the G.C.D, because there is a remainder of 5, we subtract 5 in each case. So 181, we subtract 5, we get 176, and then the 236, we subtract 5, we get 231. So these are the two numbers that you're going to get the G.C.D. So G.C.D 176 and 231, so that you can be able to get that greatest number that when we divide it by 181 or by 236, we are going to have a remainder of 5. So we first remove that remainder so that we can be able to see now the G.C.D of now those two numbers. So we check whether 2 is divisible by the two numbers. No. 3. We check 1 plus 7, 8 plus 6, 14. No. 5. No. Then 7. You can divide by 7. We check. So maybe by 7 here, we're going to get 2 because of 14. We made 336, not visible by 7. So we go to the next one, which is 11. So alternate sum 1 plus 6, 7, 7 minus 7, 0. Then for 2 get 1, 2 plus 1, 3, minus 3, 0. So 11 can divide both numbers. Okay, so 17 divided by 11, you get 1 because of 11, minus 6, 6. Then to that one, 2 because of 22, remainder 1, 11, divided by 11, 1. So no other common factor. So our G.C.D in this case is going to be 11. So 11, it is that greatest number that you can divide by 181, and the 236 of the remainder is going to give you a 5. Maybe you can check with 181. 181 divided by 11. So 11 goes 1 times 181, remainder 7, 7 to 1. We're going to be having 6 because of 66. So 11 minus 6, that is 5. Then remainder 5. I'm able to say that you have a number there and the remainder is 5. So that's how you can be able to solve that kind of a question. So thank you very much for your